Good afternoon. Today's topic is generating function models. Now, in this topic, what we study is suppose if we have a constraint on the equation, suppose the equation is given as e1 plus e2 is equal to r, and on e1 and e2 we have certain conditions such that suppose e1 should be less than or equal to 2. It should be an integer less than or equal to 2, or else e2 should be even numbers between 1 and 7. It should be only even number. Okay, and we want to find the number of non-negative integer solutions to this equation. Then we can also use the generating functions. In the previous class, we have studied the introduction to generating functions. Okay, so in this class, we will continue with the same, but we will see the usage of generating functions in such type of problems. Now, suppose what we do in this case is we take this e1 and e2, write it in the form of generating functions. So let me write it stepwise. Write this equation in generating function form. Okay. Then after that, we need to find what is the solution for our problem. The question is number of non-negative or basically positive including 0. Non-negative integral solutions for the given problem with this kind of constraints. So in this case, what we are doing, we are writing this equation in the generating function form. Okay. And the next thing is we need to find coefficient of x power r in the generating function. Okay, let me explain this once again. Suppose E1 can have the values of 0, 1, 2, okay, and E2 can have the values of even number between 1 and 7. So basically 2, 4 and 6. And suppose if I am taking R is equal to 2 or maybe, yeah, 2. Then in this case, if R is equal to 2, how many solutions will be there for E1 plus E2 where R is equal to 2? What is the solution? So if in this case E1 is 0, E2 is 2, then it will be 2. Are there any other solutions? No. But suppose if you're taking a bigger problem where the constraints are more, or you're taking your range, the range of numbers that you can take for E1 or E2 or both of them is more. That is, instead of E1 being from 0 to 2, I am taking E1 from 0 to 12 and E2 being from 1 to 70 and R I am considering as 40. Then how many solutions are there? It will be difficult to find solutions for that type of problem where your range is more or where the conditions are more. So instead of E1, E2, we have E1 plus E2 plus E3 plus E4 and so on. So in all of these cases, it is difficult to find the solution. So what is the better prospect, better a solution is to write this equation in generating function form and then find the coefficient of x power r, where r is this value in the generating function. Okay, so for this, let me do this with the help of an example. So if E1 and E2 is equal to r, then what we consider is we consider a generating function a of x which reflects the constraint on E1. A of x is reflecting the constraint on E1, while we take another generating function b of x, it reflects the constraint on E2. Okay, so whatever constraints we have on E1 and E2, we consider two different generating functions. If we have E1, E2, E3, we will consider three generating functions. So this is the way we are considering. Now after that, what we will do is we will create the generating functions and then find x power r. Okay. So now suppose if even can only be 0, 1 or 9, then a of x, our generating function which reflects e1, can be given as 1 plus x power 9. Also, if e2 is given as, if e2 can only be even and e2 lies between 0 and 8, then what will be b of x? Then b of x will be given as, so e2 values should be even and between 0 and 8. So 0, 2, 4, 6, 8. So our b of x will be x power 0 is 1 plus x square plus x power 4 plus x power 6 plus x power 8. Okay, so this is b of x. And suppose now we have to find e1 plus e2 is equal to 7. Then we should multiply a of x into b of x, and whatever is the coefficient of x power 7 will be our solution for how many solutions are there where e1 and e2 is equal to 7. Okay, so this is the way we do it. We will see an example, but before that we will also see a few cases for the same problem. Now suppose another case 2, let's present it as, this is our case 1. If e1 can be any non-negative integer, any non-negative integer, then any non-negative integer means from 0 to infinity, even can be anything. Then our a of x will be given as 1 plus x square and so on up to infinity. Similarly, e2 can take integral values, that is, it can take integer values which are multiples of 5, which are multiples of 5. Now in this case, b of x will be taken as 1 plus x power 5 plus x power 10 plus and so on. So basically we are taking multiples of 5, 0, 5, 10, 15 and so on. And this will go on up to infinity. Now we have seen till E1 and E2. What if we have E1, E2, E3? So similarly, it can be done. So we can extend what we have set to equations with more than two variables. So instead of E1, E2, E3, I am taking EI, and then we can write this in general form or more formal power series. So product of formal power series which extends to 3 factors. So instead of 2, now I am taking 3. And instead of considering constraints on this EI, I am writing a general form. So I'll write a of x, which will be equal to I is equal to 0 to infinity ai x power I. So a is the coefficient of x. So if we have x power 0, x power 1 and so on, then this is our a of x. Depending on the constraints, we can write it in the specialized form. Now we have b of x. For that, I'll take another variable over here. J is equal to 0 to infinity bjx power j, and c of x can be written as k is equal to 0 to infinity ck x power k. Then What will be our x power r coefficient? Or let's see that we have to multiply e of x into b of x into c of x. It will give us some value r is equal to 0 to infinity pr into x power r. Okay, so our series, when we multiply, we will get, it will be e1 plus e2 plus e3. Okay, this multiplication. Now if we want to find some x power r, some constraint, then we need to find this coefficient pr. What will be this pr? Where pr is equal to I plus j plus k is equal to r ai bj ck. That is, this term pr, x pr into x power r in the product is obtained by taking any one term aixi from a of x and any one term from b of x, that is bj x power j, this is j, and any one term from c of x, that is ck x power k. What is the condition? How should we select the term? The term should be selected in the way the condition is I plus j plus k is equal to r. Of course, we can take this with respect to a multiple. So instead of 3, we can have 4 generating functions, 5 generating functions, and it can be exceeded. Now, based on this, we are stating a definition or a rule. The rule is that assume that each non-zero coefficient of each formal power series aix is 1. Then the coefficient of x power r in the product a1x. So instead of a, b, c, we are taking a1, a2, and so on up to an. Can be interpreted as the number of non-negative integral solutions as the number of non-negative integral solutions to an equation e1 plus e2 plus and so on up to en is equal to r, where constraints on each ei, so each of these ei, where constraints on each ei are determined by exponents of the ith factor ai of x. Okay, so whenever we want to find ei constraints, then they are determined by the exponents of the ith factor. Now, instead of this, suppose instead of the generating function, we have been given the constraints. Then also we can reverse it and find the solution. Now, based on this, it is better if we see a problem. So suppose the question is, what is the coefficient of x power 9 in 1 plus x cube plus x power 8 whole power. Now, for this, the solution can be, this can be written as 1 plus x cube plus x power 8. How many times? 10 times. This will be our a1 of x into a2 of x and so on up to a10 of x. Now, based on this, we can create e1 plus e2 plus e3 and so on up to e10 is equal to, which which coefficient do we have to find out? We have to find out the coefficient of 9. So here this is equal to 9. Now what are the constraints for E1, E2 and so on? Each EI can have only 3 values. What are the 3 values? X power 0, x cube and x power 8. So 0, 3 and 8. Now what are the solution for this? When we have to find the coefficient of x power 9, it means we have to find this equation. Now 3 values, when will we get 9? When we will get 9 only in the case when any 3 EIs are equal to 0, that is 3 values are equal to, sorry, not 0, 3 values are equal to 3. So suppose if we are considering E1, E2 and E3 as 3, then remaining values are 0. Only then we can get this 9. So that is only there is one solution. Suppose similarly, if we want to find the coefficient of x power 25. In the case of x power 25, coefficient will be how many total different E constraints E's are there? There are 10 factorial by now. How will we get 25? Each solution will involve 3 threes, that is 3 values should have this 3, okay, 2 eights, 2 we can take 8s, and then 5 values should be zeros. Okay, what does this mean? Suppose if E1, E2, E3 are 3, okay, and E4 and E5 are 8. So 3 plus 3 plus 3 plus 8 plus 8. This will give us 25. Now the rest values all should be 0. So this is our solution. So in that case, our solution will be coefficient of x power 25 is 3 factorial. Okay, we are taking 3 threes, which can be any of the 3 values. So 3 factorial by how many 8s? 2 8s. So 2 factorial into 5 factorial. Similarly, for x power 9, if you can guess now, the solution will be 10 factorial by, we are taking 3 threes, so 3 factorial. The rest 7 values are 0, so 7 factorial. So this is the coefficient of x power 9. Now, based on this, let's see another problem in 1 plus x power 5 plus x power 9 whole power 10. You need to find the coefficient of x power 23 and coefficient of x power 32. Okay. Now for 23, we can write directly. I'm writing now E1 plus E2 plus and so on up to E10 is equal to 23. What can be the value of E1, E2? It can be either 0, which is x power 0, 1, or x power 5 or x power 9. That is where EI is equal to 0, 5, 9. Okay. Now in how many ways will we get 23? That we have to check. That is manual work. So suppose if I am taking all zeros, no. If I am taking all 5, I won't get 23. But one scenario is if we take 2 nines, 2 nines are being taken. That is, I am considering E1, E2 as 9. Okay, I am giving the value 9 to E1 and E2. Next, 9 plus 9 will give us 18, and if I add 5 to it, it would become 23. So suppose E3 is getting the value 5, and all the values from E4 to E10 are 0. Okay. So how many 9s am I taking? I'm taking 2 9s. I'm taking 1 5. 5 is being taken only one value, and all the rest of the values, how many are left? 3 values have been taken. All the 7 other values are equal to 0. So now what is the coefficient? The coefficient will be 10 factorial by how many 9s? 2, which can be given in any two ways. 2 factorial, then 5 in 1 factorial way, and then 7 factorial. Now you might get it out that why are we using this formula? So if you remember, we used this formula when we were finding the number of arrangements for the words like success, Mississippi. What was the question over there? We had repetitions. So here also, when we are filling the blanks of E1, E2 and so on up to E10, we have repetitions, that is we can have the same values, and also we need to find that the coefficient of x power r. So in this case, we will take the same formula where it will be n factorial by how many 9s we are taking, that factorial, how many 5s and how many zeros, or the number of whatever the constraint has been given, how many number of constraints you are taking, that will be the denominator. Now similarly, coefficient of x power 32, how can we obtain 32? So suppose I can take the same thing, instead of 23 we have to write E1 plus E2 plus and so on up to E10 is equal to 32, where the same values of EI are taken, where EI is equal to 0, 5, 9. Now here, if we take suppose 3 9s, 9s are taken 3 times and 5 is taken 1 time, 5s are taken 1 time, and all the rest 7 values are zeros. Okay, not 7, 3 plus 1, 4 blanks have already been filled. So we will have only 6 values. So all the rest 6 values are 0. What is the coefficient then? The coefficient will be 10 factorial by 3 factorial into 1 factorial into 6 factorial. So this is the coefficient of x power 32. Now similarly, one problem you can solve as a practice problem is find the coefficient of practice problem. You can solve it. I'll give you the solution. Try solving it. Coefficient of x power 16 in 1 plus x power 4 plus x power 8 whole power 10. Now in this case, we will have different kinds of coefficient. So if you notice x power 16, I'll try solving it over here. So E1 plus E2 and so on up to E10 is being taken as 16. How many ways are there? There are actually 3 ways where EI value is equal to 0, 4, 8. Now what are the 3 ways? Suppose if we take 4 fours and rest all zeros. So we are taking 4 fours. So the first, there will be 3 ways we do it. All 4 fours, 4 fours, no 8s and 6 zeros. Okay. The second case will be 2 8s, no 4s and 8 zeros. And the last case will be 2 fours, 1 8 and 7 zeros. So in this case, for this we will write 10 factorial by 4 factorial into no 8, so we are skipping it, 6 factorial. For this we will write, for the second case, let me write it over here, 10 factorial by 2 factorial and no 4s, we skip it, 8 factorial. Here we will be writing 10 factorial by 2 factorial into 1 factorial into 7 factorial. Okay. So this can be written as, the actual total solution will be given as 10 factorial by 4 factorial into 6 factorial plus 10 factorial by 2 factorial into 8 factorial plus 10 factorial into 2 factorial 1 8, so 1 factorial into 7 factorial. So this is the solution. Now you might get a doubt that in this case we got only one factor. In this case also we got only one factor. Why are we getting this kind of coefficient for the other problem? The reason being, for x power 23, there is only one way to take the values, that is, there is no other solution for x power 23 apart from this one, that is taking 2 9s, 1 5 and all the other zeros. But for x power 16, we have three different ways. So you have to consider all the ways to write the coefficient. So this is the reason we are getting this type of problem. Now, so I said as vice versa is also true. So suppose if we are given the constraint in this way and we are given the equation in this way and the constraints are given as follows. So E1 lies between 0 and 3. E2 also lies between 0 and 3. E3 lies between 2 and 6. E4 lies between 2 and 6 and E5 is odd and lies between 1 and 9. Then in that case, what is the generating function for AR? It can be given as, so E1 I am representing it with A1 of x, E2 is A2 of x, E3 is A3 of x, E4 is A4 and E5 is A5 of x. Now in this case, the generating function for A1 will be between 0 and 3. So 1 plus x square plus x cube, 0, 1, 2, 3. Similarly for E2, it will be the same thing. For E3, we will have 2, 3, 4, 5, 6. So x square plus x cube plus x power 4 plus x power 5 plus x power 6. Similarly for E4, I will have the same thing as A3, so that is same. Now A5 will be odd values between 1 and 9. So it will be 1, 3, 5, 7, 9. So let's write A5. It will be x plus x cube plus x power 5 plus x power 7 plus x power 9. Now how do we represent it? Instead of plus, we will be writing into. So it will be written as A1 of x into A2 of x into, yeah, 1 second, into A3 of x A3 of x into A4 of x and A5 of x. which will be given as 1 plus x square plus x cube, which is our a1. a2 is also the same, so we take square. a3 and a4 are same again, so x square plus x cube plus x power 4 plus x power 5 plus x power 6 whole square, and a5 is given as follows. So this is the solution for our question. Similarly, if you are given the questions in the form of a problem, you can do the same way. So the next question is, write a generating function for AR when AR is the number of ways of selecting R balls from 3 red balls, 5 blue balls and 7 white balls. Okay. Now suppose we consider them as E1, E2 and E3. So in this case, suppose if we have 3 red balls, 5 blue balls and 7 white balls respectively. So from E1 we can select either 0 balls or 1 ball or 2 balls or 3 balls. From E2 also 0, 1, 2, 3, 4, 5, and similarly from E3 0 to 7 balls. Okay. So what is the coefficient? So let's take that directly. Instead of E1 I'll take A of x, B of x and C of x. Okay. What is the question? It is being asked that E1 plus E2 plus E3 is equal to R. Find the coefficient of x power R, which will be AR. So now we will write it as A of x into B of x into C of x. Okay. So that can be written as A of x is 0, 1, 2, 3. So 1 plus x square plus x cube into B of x is 1, 2, 3, 4, 5, 0 to 5. So 1 plus x square plus and so on up to x power 5. Please fill in the between terms. And then we have C of x as 0 to 7. So 1 plus x square plus and so on up to x power 7. So this will give us the solution for a power r. So whatever the term is for x power r, that will give us AR value. Okay. Similarly, any type of problem given in this way can be solved with respect to generating function models. Now, in the next class, we will see calculating coefficients of generating function. So, how to calculate the coefficient.